When we look at children and youth who have been affected by alcohol exposure and try to assess them, we think about them from the perspective of information processing. That is how the brain takes information in and uses it. And it's a four-step process. The first step is input, information coming in. And the important thing to remember is that the different kinds of sensory information that surround us every day come into the brain along different pathways. So for instance, vision, anything you see, enters the eye, travels the whole length of the brain along the optic nerve and inserts in the back of the brain, and that's called the visual cortex. Anything you hear comes in through the ear, travels and hits the midline of the brain. So auditory or hearing information comes in and hits the midline of the brain. Taste, touch, and smell come in through the parietal lobe, which is almost at the top of the brain. And so you have all of this sensory information coming together, and the job of the brain after input, the second step, is integration. That is, how do you bring this information together and integrate it so it makes sense? The third step is memory. How do you store the information in the brain so that when it's time to use it, you can use it? And then finally, the fourth step is output. How do you use the information to guide your behaviors and actions? In order to use information, you have to take it out of storage in the back of the brain and move it forward to the regulatory center of the brain that's called the prefrontal cortex. And the prefrontal cortex has catecholamines, the most common of which that's known is dopamine. And dopamine, when that information hits the prefrontal cortex, dopamine fires off and tells you how to respond to the information. So a good example is if you're walking down the sidewalk and you come to a street, what do? You look to see if any cars are coming, and let's say a car is coming. That visual information enters the eye, hits the back of the brain, the visual cortex, flash, there's the car. That information then shoots forward to the prefrontal cortex. The dopamine fires off and says, stop walking. That's called motor regulation. Now, where alcohol damage comes into all of this, alcohol can affect all different parts of the brain. But one of the key areas it affects is the midline of the brain, which is called the limbic system. And the limbic system helps transport that information out of memory up to the prefrontal cortex. So now, for example, a child with fetal alcohol exposure, they're walking along the sidewalk, they see the car coming, but as that information then tries to move forward to fire off the dopamine, it gets stuck in the limbic system. And so the child sees the car, but just keeps walking. And that's why so many children with alcohol exposure get diagnosed with ADHD, attention deficit hyperactivity disorder, because they're impulsive, they don't think through, they don't use information to regulate their behaviors.